right, we're back. It was just a short break, and welcome back into the new next talk. Next up, I would like to welcome to the virtual stage Anshu Agarwal with a talk on simple to manage multi-cloud serverless stack for your Kubernetes infrastructure. Welcome, Anshu. How are you doing today?
I'm doing great, Dominique, and thank you for having me.
Excellent, excellent. So just before we went into the talk, I was asking you about, could you tell me a fun fact about yourself that nobody knows? And just before you were about to answer, we got interrupted. So I'm sorry to put you on the spot, but could you tell us a fun fact about yourself?
Sure, sure. I don't know if it is really fun fact, but it's interesting, and it's definitely interesting to my kids. So I'm going to date myself. I used to do AI when AI wasn't cool. So
So you're the original AI hipster.
that's right, that's right. And I gave up on AI in 1999, I suppose, because there wasn't enough compute, there was not enough data. But I was working in AI for almost 8 years until then. My thesis was in neural networks, and when my kids hear that and says, "You knew neural networks in the 90s," as if like, 90s was such a long time ago. So that's a fun fact. That's a fact. I don't know if it's
That's
fun or
cool,
not,
though.
but yes, I
Yeah,
was doing AI.
yeah. I mean, speaking of like the younger generation, I heard somebody refer to 1999 as the late 1900s. When I heard that, I was like, oh, right in the age.
Yeah, yeah, yeah. When my kids hear it, it's just like, 1990s. Oh my gosh.
90s. Anyway, we're digressing, but yeah, don't for everybody watching, don't forget to ask questions on the Slido on the chat for Q&A we'll have after your talk. Okay, take it away, Anshu. Have fun.
All right. Well, thank you, Dominic. So, hello, everyone, in whichever time zone you are. My name is Anshu Agarwal, and I am the CEO and co founder of Nimbella. And Nimbella is a serverless platform provider. So, today I'm going to talk about a multi cloud serverless stack for Kubernetes. We believe it is a right way to run a serverless stack, and it's definitely a strong opinion. But in this talk, I will explain my reasons and why enterprises should be concerned about multi cloud from the get go when they are making decisions regarding their tech stack. Enterprises are going to cloud because it is an elastic environment. Earlier, we were using data centers, which were a static environment. Later, VMs helped us scale on demand, but they are still very coarse grained. The way we split things is using containers, which is like splitting VMs into smaller pieces. And containerization is really popular. And so today's Zen of Cloud is to implement fine grained microservices and then using Kubernetes to orchestrate it all. Kubernetes is very popular, and I am kind of preaching to the choir here. But if you go 3, 4 years ago, it was mostly in dev and test environments, and now more than 50% container environments are using Kubernetes in production. In fact, if you look at all the incarnations of orchestrators, Kubernetes has won the battle and has become the de facto standard for orchestration. It is not, if it's not being used today, it is certainly on the technology infrastructure roadmap of every CIO and is a mandate. But why is it so popular? It is popular because it is cloud native by construction. And cloud native, a lot of people think cloud native means that you have to be in a public cloud, but that's not what cloud native really means. Even the creator of Kubernetes defined cloud native as it isn't where you operate, it is how you operate. So it is portable and flexible in terms of use. It auto scales your infrastructure. It's completely extensible. It is open source and therefore no vendor lock in. And if I were to summarize why Kubernetes is so popular, it is the cloud normalizer for multi-cloud, hybrid cloud, and private cloud deployments today. But all is not well in the wonderful land of Kubernetes. This is a warning because I'm going to share some pictures, disturbing pictures of how developers and DevOps are feeling in this brave new world of Kubernetes. All right. You guys must have seen this already, but this is how developers feel about Kubernetes. It is complicated, and developers don't want to spend their cycles on learning the details of Kubernetes, but want to focus on their code. Infrastructure is absolutely necessary, but developers spending time on infrastructure doesn't add any value to the business. In fact, they're not even measured on how well they know their infrastructure, how well they're operating the infrastructure, but what they have created for the business. It is a steep learning curve, and developers don't want to pay the price for it. So what is Kubernetes missing? There are two more. There are two important points, and one is automated image creation, and the other one is a ready-to-use architecture. Now let's go over how we build from scratch in Kubernetes. We are using Jenkins to automate a pipeline of things, building things with code, using Git, building with Docker, putting a Docker registry, doing configuration of Kubernetes, and load balancing from cloud to deploy the application. Furthermore, if we double click on Kubernetes, just the Kubernetes part of it, you can see that we have to set up so many YAML configurations, such as stateful sets, daemon sets, persistent volumes, set up master nodes, worker nodes. It is a lot of work to be done before you move your code to cloud. And doing it in iterative development process, this is all adding inefficiencies to your development process. So in the end, development on Kubernetes is very complex. And it takes away developer productivity. If every developer has to know that. Another way of doing developing in cloud is using public cloud serverless offerings, and it is a ready to go architecture. This is a Hello World example. You push the Hello World code in Lambda or Google Cloud Function or Azure Function, automatically creates containers. And it publishes the application. The architecture is ready to go, and that's why it is so popular. And there are several benefits of serverless. Fundamentally, serverless is about running backend code without managing your own server systems or own server applications. And since there are no server applications to run, huge time savings from DevOps perspective. Horizontal scaling is completely automatic, elastic, and managed by the platform provider. True pay as you go, no paying for idle capacity ever. Deployment is very different from traditional systems. You upload the code to the fast provider or the serverless provider, and it does everything else. All of this results into faster development and deployment time, and that results into faster time to market. So you're not only reducing your development costs by making your developer productive, but you are going to the market faster, so you are increasing your top line. So it's benefits on the top line and the bottom line both. And this is the reason why developers feel this way once they start coding with serverless paradigm. But the problem of most serverless offerings is that even though it is easy way to develop, the abstractions that are built for each cloud to provide this ready-to-go architecture are different, and they are very cloud specific. So it results in cloud vendor lock-in for the organization. And since developers have to code to different cloud vendor APIs, they have to learn about every cloud. It results into lower developer productivity. So the benefits are not, you're not reaping in all the benefits of serverless if you're doing that way. But can we not have both serverless and Kubernetes? Can we not have the portability of Kubernetes and ready to go architecture of serverless? Actually, we can. And this is what makes the entire stack multi-cloud. There are several solutions which run on Kubernetes and they run on various cloud providers. So we see serverless not as a proprietary layer, but as a portable, ready to go architecture. So we can use a standard architecture. It is possible to build a standard architecture from scratch as long as we put all the pieces together for cloud native applications. Load balancing nodes and services, auto scaling as your need for scale increases, managing back pressure, which is ability to store requests that you cannot service right away, logs and visualization for the developers, and then automatic image creation. So let's go over in detail all of these requirements that we have. Not just a single service. Load balancing is not for just a single service, but globally scale across different services. So you need a load balancer there. You need a controller to manage scale automatically. So new microservices and new nodes are added as needed. Managing back pressure. This is actually not a very well understood requirement. This is when you have to buffer request in case there is a sudden increase of request. When system cannot satisfy right away, so they are put in a message queue to serve later. Logging and visualization and observability, it's for storing the log events and also real-time visualization. And then last but not the least, automated image creation. This is basically having stock runtimes, pick up from the stock runtime, initialize and run, which is actually the real magic of serverless. Basically, you push your code, everything is done by the platform, the container is created, the runtime is selected, and it's executed. So one of the systems that satisfies all requirements at enterprise scale is Apache OpenWhisk. You have Nginx for load balancing. You have controller for scaling, Kafka for managing back pressure, invokers to create new runtimes, and CouchDB for storing logs. So all the requirements of an execution engine are satisfied using open source and open standards by the system. And now you have a serverless compute architecture in Kubernetes, which is ready to go and ready to use. But the serverless promise is actually bigger than serverless compute. All we talked about until now was serverless compute. And so now let's talk about what is a serverless promise. The definition of serverless has expanded. It's not just functions, it has containers in terms of compute, but there are other aspects to an application. It is the ability to easily deploy, manage, and operate. It is partially accomplished with the serverless compute, but you are still dependent on the cloud. The second is no worry about the infrastructure, but applications, as I said, is not just functions. All real applications are doing something with data. And there are many, many forms of data. And the kind of storage that you need is different. So if the application has a front-end UI, you upload those assets to an object store. That's one form of storage. If you are handling session state and transient data streaming properties, you might use a key value store. That's another form of storage. If you are handling files and your application needs to process images or PDFs, you need a file system. And you need, as a developer, you need a declarative approach to these so they are all available when a developer needs it. They scale in a serverless manner, so a developer's responsibility does not include management of these resources or backing up the data. The last one is basically code once, run anywhere, which means you should have a uniform programming model that allows you to code the way you code and the ability to run anywhere in any cloud. One of the stateful architecture that is built using OpenWhisk is Nimbella, and I apologize that this is my one shameless plug for my company, but to show you a demo, I will have to tell you a bit about the platform. So it has 5 components: developer tools that are for developer facing, and the management tools that are for deployment on Kubernetes in case you're deploying. Serverless compute is based on OpenWhisk, but there's also serverless storage and memory that's exposed to the developer in form of APIs and can be consumed in the application in declarative manner. All this is done with a open API, so your code is independent of the cloud that it runs on. So these are the developer tools that that the developer has. As you can see, it's a developer command line, and it can run in browser. And I'm going to show a couple of these commands being executed so you can appreciate how the deployment happens with just one command. And then, since this is a session for SREs, I think it's really important to talk about management tools, basically CLI that pushes the entire system, which is all the components that I showed you, with one command, and it takes dozens of kubectl commands. It's abstracting kubectl commands to configure and prepare your Kubernetes environments to run a serverless stack, along with a dashboard, which is a Prometheus dashboard, again, open source, and is available. So now, if you bear with me, I'm going to switch to another screen to show you a demo. All right, I apologize for the size of this. This is a recording. So this is the browser CLI that I mentioned. You are selecting a particular namespace, which is authorized. You take a project, and this is the command, nim project deploy using GitHub project. And it's a QR code project. Basically, it's generating a QR code, and one command pushes it. And as you can see, this is one API that has been created, API endpoint, and it has web assets, and also it's running on Google Cloud. So I'm going to just run it. It's a QR code running on Google Cloud. Now I'm going to actually publish using the same code, but switch the namespace, same code, and on AWS. So it is running on EKS, which is AWS Kubernetes, and I'm going to deploy again. And it's a new API endpoint. Again, same code, same application, but a different cloud. Same command. So now it's running on AWS. You can also see actions. So that's the QR code action, which is the function. Now I'm going to show you the activation, where you can see the code, very simple code. Okay, and there's nothing funny about the code. It's just the way you code it. And the activations can show you how long it took, whether it was the web assets or the QR code. Okay, I'm going to go back to my presentation now. All right. Okay. So if you like that demo, there are several demos like that, and there is one particular demo, which is the chess demo. You can see it runs on 5 different clouds, same code, no difference, and it can run easily on 5 different clouds without modification. So again, if we were to look at the serverless promise, so was it easy to deploy? Yes, the developer tooling made it really, really easy to deploy, and one command pushed your code to the cloud. Are we managing infrastructure? Absolutely not. Compute, storage, and networking all were managed by serverless platform. And it is about freeing the developer from having to think about various things. If you want a concept of key value store, you should be able to use it, not think about where it's provisioned, how it's provisioned, and how it is backed up. It is the programming model that is uniform across all clouds, and it broadens a set of capabilities that just not only functions do, but serverless programming in general allows you to do. So if you were looking at from a responsibility standpoint, logic is still the responsibility of the developer, where it should be, and everything else is managed by the platform. Were you able to code once and run anywhere? Yes, we did. We showed it in 2 clouds, but you can run it in multiple clouds, same code. Nothing changes. So if you liked what you saw, you can check out more examples on nimbella.com. We are also running a fun competition. It's a challenge. It's building your serverless Jedi. It's a bot game, and you code your serverless Jedi. You have fun playing the game, and you can also win cash prizes. Please join our Slack community channel, and I'm going to take questions now.
Excellent. Thank you so much, Anshu. That was great. Yeah, I mean, I'm liking the Fast Wars. I'm very much a Star Wars fan as well. So, I mean, all kinds of like sci-fi, starry space stuff. So, yeah, let me just have a little check. Charlotte, did we have any questions?
Yes, we do. We have two questions. The first one is Nimbella compatible with existing serverless services?
Nimbella is a serverless platform. It's compatible with Kubernetes. It runs on any Kubernetes, but it is a serverless platform of its own. So it doesn't use other execution engine. It uses Apache OpenWhisk. It's open source based for execution.
So it's like, would you say one of your competitors would be OpenFast?
Yes, but we are multi-tenant. We are not just running on a single tenant. So you can, if you wanted to run a service, you could run a service. So it's a multi-tenanted service. Yes, you are right. But this is managed and hosted by Nimbella, plus also completely installable on any Kubernetes.
All right, cool. I think one of the other questions was, do you support clouds other than GCP and AWS? Or
yes,
probably like AKS and GKE and all that kind of.
Yeah. So we run on GKE. So you could run in your virtual private cloud in Google, or you can run in virtual private cloud in Amazon, or you can run a virtual private cloud in Azure. We can run on AKS. We are not running our current service on AKS, but you can deploy the installable version on AKS. We also run on PKS. We run on vanilla kube. So if there is Kubernetes, you can run it.
Sounds good. I think that was it. Do we have any other questions? I think
that was it for questions. I have one actually just about the talk. What is the one thing you would want people to take away from this?
The important thing I would like people to take away is that you chose Kubernetes because you wanted it to be the cloud normalizer. So don't get locked into a top level stack, which is proprietary, because it is very, very hard to migrate. You still use the public clouds, all the public clouds, wonderful scaling, wonderful everything, but go with a full stack of non-proprietary, because it's easy to move your workloads from cloud to cloud. Also, some clouds may be good at something and some clouds may be good at something else. So you want the best of the clouds. You want to democratize your developer experience, but also use clouds as a commodity. And you can only do that if you're not locked into proprietary infrastructure.
Perfect answer for a multi-cloud track. Thank you.
All right.
Multi-cloud is the future.
I did have one thing. Did you guys lose me for some time?
There was one moment where you were like gone for like 1 or 2 seconds. It was like, should I jump in and say something? But then you just like flip back. So it was just about. It was.
I didn't even realize it. Sorry about that.
No, it's all right. I think we have one more question that popped in on the chat. In general, how to include continuous integration with serverless, in your opinion?
Oh, it integrates with the regular GitOps tools. So you have like we eat our own dog food. So everything is developed in serverless, and we use Jenkins, we use Jira, we use all the tools that are there for making the life of DevOps and developers simple. And it's completely integrated into the DevOps pipeline.
Excellent. All right, with that, I think we're at our time roughly. Or do we have any more? No, I think we're good for questions now. If there's anything else, you feel free to. Are you staying for the rest of the show?
I will go into a couple of sessions, but I'd highly recommend play the Fast Wars. If you didn't know serverless, you'll not only learn serverless, but you'll have fun doing it.